Hey everyone, and welcome to Versent's AI webinar series. My name is Jaden Kerr, a senior software engineer here at Versent, and I'll be your host for the next 2 weeks. Thanks for joining us as we explore the ever-evolving world of AI. In this series, we'll dive into what's possible today, what's coming next, and how to navigate AI responsibly. Each session, we look at real-world use cases, practical frameworks, and expert insights to help you move forward with confidence. Today's session will discover how Versent's reimagined workforce planning with PixieOps, an AI-powered orchestration agent built on AWS Bedrock Agents. Here's today's speaker, Gareth Williams, Principal Solution Architect, on their talk, Optimizing Workforce Planning Using Orchestration Agents. Over to you, Gareth.
Okey-doke. Cool. So, hello, folks. I'm Gareth. Thanks, Jaden, for the introduction. If anybody has any questions, please do drop them in the chat window, and we'll get to them at the end if there's time. So, optimizing workforce planning agent using orchestration agents. As I said, I'm Gareth Williams. I'm a principal solution architect at Versent, and I've been concentrating on AI for the last year or so. What is an agent? So let's start off with some definitions. An agent is a system that perceives its environment, makes decisions, and takes actions to achieve a goal. So in the example that I've put on the right-hand side, you can see there's an orchestrator agent that is receiving input, and then it is able to delegate tasks to various sub-agents. So we have a research agent that is specifically crafted for the process of researching using the web, using knowledge bases, and then it passes that data back to the orchestrator, which then goes on to the writer agent, which is able to write a report based on very specific instructions that are tailored to that agent. Then the orchestrator passes that response on to the critic, which is able to assess the claims, judge the quality, and demand any changes before returning that information back to the orchestrator, which can then enter into a loop. So it can go into another research cycle, another write a new report, or whatever it is that it deems necessary before responding to the user. So that's clearly perceiving its environment, making decisions, taking actions, and then achieving a goal. Key considerations when you're building an agent. So the first couple are kind of common across data practices, but making sure that you have consent and legitimate interest for using any data that you happen to collect in the process of interacting with the agent. Data minimization and purpose limitation. So that's making sure that you collect only a minimal amount of information that is against a particular purpose that you have prior stated. And then more of an AI specific group here. So you've got training data provenance. So making sure that the data has come from legitimate sources, it isn't copyrighted. And similarly, when the model is running, is that running in a geography that is appropriate for your particular application? So it might be shipped off to the US, and you need to be aware of that when you're building the agent. Another consideration is human impact. So there's a lot of talk about how AI is perhaps going to impact humans and the workforce. So involving those individuals as stakeholders throughout the process of building the agent is hugely important. And then also there's a right to explanation. So making sure that you can look at the agent, see what it's been thinking or why it has taken a particular action. So the observability of it so that it doesn't erode trust and has accountability. Finally, there's testing. So making sure that you have thoroughly tested and evaluated the performance of the agent against accuracy, completeness, making sure it's not toxic in any way, shape or form. And yeah, stopping it from having reputational detrimental impact on your business. So for our particular use case, we were given the following problem statement. Workforce planning depends on weekly meetings, reports take hours, and those reports are outdated shortly afterwards. So can AI make this a real-time self-service operation? To achieve this, we employed a few emerging common patterns that are in the AI industry at the moment. So first of all, there's RAG. So RAG is the processing of unstructured documents, docx files, PDFs and the like, chunking up the data into useful subsections and then turning that into numerical representations that can be searched semantically. So rather than having to look up particular keywords, you can get the semantic meaning of particular chunks and search against that instead. Hugely powerful. You then have the AI orchestrator pattern and the use of multi-agents. So this is particularly useful because you can create very specific and tailored prompts or sets of instructions for smaller agents that can collaborate together to achieve an outcome, rather than giving it to all the instructions to one agent that might see less effective results as a result. Then there's guardrails. So this is making sure that the agents are safe and ethical, so they're not responding in a toxic manner or responding to questions that are perhaps off topic. So making sure that the agent is sticking to the purposes, in our case, of workforce planning. There's tool use as well. That's a common pattern at the moment. So tailoring the particular tools to the sub-agent. In our case, we used a tool to look up biographies using RAG. And then there's also direct API integrations with the likes of Snowflake. So building tools that were specific for those purposes and attaching those to relevant agents. We then used the evaluation pattern. So that is using an AI LLM to evaluate the outputs of our agent and make sure that it was appropriate for the giving appropriate responses that were accurate, complete, used appropriate tools, and were not toxic in any way, shape, or form. Then there was prompt and context engineering. So this was making sure that we gave the agents appropriate instructions to complete its task and respond in an appropriate manner. And then also making sure that it has enough information inside of its context window so that it can actually solve the problem that you've asked it to endeavor to fix. So agents as tools. We built some specialized agents, as I mentioned before. We have the utilization agent, which is associated with or attached to a utilization tool that is able to go away to Snowflake and look up a resource's utilization data. It is able to filter by name, their practice, date ranges, things of that nature, so we can get the utilization rates of resources. Then we have the BIOS agent. So that is connected to a couple of tools, the first of which being the ability to look up via RAG the biographies of the staff members that exist in Versent and look at their various skills, their experience, certifications, things of that nature, and find the correct person for the particular query that's been asked of the agent. You then have the bio generation tool. So this is the ability to then ask the agent to go and update your biography if it is out of date, tweak it in some way, shape or form. So it's updating a docx or a PDF file on behalf of you, making that process a little bit easier and reminding you after a set number of months that perhaps your biography is out of date. The agent flow looks something like this. So if you start off at the left, you've got the Versent user. They're conversing with the agent using Slack. That speaks to the orchestrator agent, and the orchestrator agent is then able to delegate tasks to either the utilization agent, which uses its bundled tools to speak to Snowflake, and therefore it's able to access information that exists from Salesforce and Workday. And then you also have the BIOS agent, which is able to use the bio knowledge base tool to speak to the associated knowledge base. We've stored the vectors inside of S3 vector. So then you're able to do that semantic search and get some rich insights based on queries rather than keyword-based patterns. And then finally, there's that BIOS generation tool, which is the connected to a Lambda that is able to create PDFs and docx files and save those back to SharePoint. On the right-hand side, again, if you look at SharePoint, you'll see that there's an extractor. So that is pulling out those biographies that are a rich source of data for our purpose, saving those files into S3. And then we have a Lambda that is able to process all of those files using a Bedrock embedding model and an LLM. The embedding model is creating those vectors that are stored in S3, but before it does that, the LLM is able to infer useful information such as what industry you might have worked with in the past, and the level of your experience or something such as that. So, a demo. I've pre-recorded this because of latency issues, so I can tighten things up. So first of all, we have a query for what principal engineers are available in November with Azure expertise. So this is going to look up biographies, first of all, and look for individuals that have got previous experience with Azure. It's then going to give us a list of those names, and then the agent is then able to go to the utilization tool and associated agent and look up the availability of those particular names as necessary. So this way you're able to sort of split the various component parts of the process into dedicated agents that are experts at their particular task. And in combination, they're able to give us some rich responses. So if we just wait for the agent to get back to us, one reply. Here you can see that the agent has responded with some principal engineers with Azure expertise. So it's given us 2 as an example. It's also responded with their additional skills, their availability, and then it's also come back with some additional candidates that perhaps don't match the same title, but do have similar sort of skill sets or certifications and availability. So it's quite useful when we're trying to plan out a project and put together a team for that particular SOW. And yeah, making sure that we're finding the right people for the task. Next, I've gone on to ask, can you list staff with AWS Solution Architecture Associate certifications? So this is going away again to that knowledge base that is looking at the biographies. And because of that ingestion technique that we've used, where we have an LLM that is looking at particular chunks of data and breaking it up before the vectors are generated, you're able to look at very specific pieces of information like skills, like certifications. So you'll see here in the response, it's pulled through about 5 or so individuals. We're working in the dev environment here, so you're not going to see the full list of available individuals with certifications. But yeah, we can see Ahmed, myself, Richard, Justin Green, Mahesh. It's giving some additional availability information. So it's gone away to Snowflake and found that information to supplement the response. It's called out immediately the certifications of the individual and then supplementary expertise that those individuals have. Okay, next one is practice leads with healthcare experience. So again, we're going after a very specific title, which is going to go away to the biographies. This time it's going to look for healthcare related information. So every biography has a list of previous projects that you might have worked on. And then using that LLM, we're able to say, infer if that particular piece of experience was for a particular industry or sector. So first of all, the agent's going to go to the biographies, search that knowledge base, find the practice leads, and then again, it's going to go to Snowflake and get hold of the availability information for those individuals. So if we just give the agent a moment, here you can see it's pulled out a couple of individuals. So you have Mahesh here and you have Jeremy. We've got Jeremy with Calvary Healthcare there. And then we have Richard Kite, who is also as a supplementary, they're not practice leads, but it's giving us some other individuals that might be able to assist. So again, worked at the same place. And then we have Ahmed and myself, who have both worked at La Trobe Health Services. Additionally, it's given availability information and a bit of a summary at the end to summarize what it's found. Final example here is, can you assemble a team made of an architect, a principal engineer, a senior engineer, an associate engineer, a business analyst, and a project manager, all with AWS skills where relevant? So this is a more complex query where it's going to make multiple queries of the knowledge base. It's going to make multiple queries of Snowflake. It's looking for that AWS skill set as well as those various titles. and then coming back with a list of all of those individuals. So as you can see in the response, it's given a primary. So there's an architect there, Richard Kite, that it said this person has particular expertise and certifications, recent projects that demonstrate this ability. It's got their availability, and then it's got some secondary resources that you might elect to use if Richard were otherwise occupied or unavailable. And then it's done the same for senior engineer, associate engineer. It's done similar for principal engineer, business analyst, as you can see a bit further below. So you've got information about their certs and whatnot. And then at the very bottom, it does have a team summary here. So it's listing out those various individuals from this list that it thinks are the sort of the key candidates or the highest recommended individuals. I would say as well, this thread, you could go into further conversation with the agent and it would retain this context. So it would see that team and you'd be able to further refine and request, and a future embellishment of the agent is to then go into Workday and reserve those individuals for that particular project. The agent architecture looks something like this. So from the right, you've got the Versent staff member that is speaking to Slack. That goes to a hosted zone in Route 53, which routes the traffic through to an application load balancer. And then this will look similar to anyone that's done microservice architecture in the past. So this is just a containerized agent with all of the tools and sub-agents in one singular container. It then has connected to it integrations into Bedrock guardrails, Bedrock models, so the inference models like Anthropic and the like. And then you've got knowledge bases, which are attached to some sort of vector store. We've got biovectors there, which is in S3 vectors. That was a huge cost saving over the likes of OpenSearch, which is an alternative option in AWS. You're then able to integrate into Snowflake, but that's via a custom integration where we've written our own queries, and that's a function that we've integrated into the agent. So AWS Strands, so this is the Strands Agents SDK is the elected framework that we've used. This is incredibly developer friendly. The syntax is easy to interpret. You've got very simple decorators to create tools. So those functions that I mentioned about before with Snowflake, simply decorating it with an @tools string will turn it into a consumable of the agent itself. And the syntax in general of Strands Agents is very similar to Google ADK and all of those other great tools that are out there at the moment. So it's similar and easy to transfer between each of them. The other advantage of Strands Agents is that it integrates natively into Bedrock and all of those AWS services that you might elect to use. So models, guardrails, knowledge bases, and then in turn S3 vectors. So for ourselves, it was incredibly useful, seeing as that was the stack that we were building on. Then when it comes to observability and being able to get a right to explanation, as I've mentioned previously, we've set up some observability tools inside of the stack. So we've got some ALBs going into Arise, Phoenix, and Jaeger with traces stored in RDS. This is really useful for getting a sense of what the agent has done and why it has done it. So you can trace all of the various interactions. You can see the initial prompt, the thinking and the output of the agent. You can see the tools that it's used and any perhaps thoughts, so to speak, that the agent has had. And then you can also look at stuff like cost and latency. So if you look in the top left-hand corner, it's able to tell you, based on the number of tokens that were consumed, the cost of this particular query, and then the latency, so how long it took for a response. We're seeing high latency, but that is probably acceptable for complex queries which agents are able to go and perform. Then when it comes to other capabilities of Arise Phoenix, we have the ability to evaluate in real time or against data sets or beyond. So you can look at relevance and accuracy. You can look for hallucinations where it can see in these traces that a particular claim is not justified by any particular piece of data to support it, therefore concluding that it's hallucinations, or toxicity. So you can see if the outputs, the responses, or the inputs are toxic in some way, shape, or form, and get an alert before the agent goes off and causes reputational damage. And then the other advantage here is that you can build data sets around real world use cases. So when it comes to doing those evaluations that we mentioned before and making sure that the agent is fit for purpose in dev and onwards, building out those data sets based on real world interactions is incredibly useful rather than just dreaming up a number of use cases as was the case in the past. Key learnings, evaluations, run them everywhere, run them often. These are kind of the unit test of the agentic world. So it's a really useful way of between deployments, making sure that the changes that you've made to prompts or context and tools hasn't negatively impacted the outcomes that you're getting from the agent. And there's so many variety of use cases that this becomes incredibly important and incredibly useful. You don't want to be sitting there manually testing this stuff because there is endless options and paths that you can take when querying the agent. Guardrails, they're your friend, use them. So this is making sure that you can keep the agent from responding in a toxic manner or responding to toxic requests or things such as, violence, sexually explicit material, all of that sort of stuff that would create reputational damage. And it stops you having to put those guards in the prompt itself so that you can build your agent to its particular purpose and not have to worry about these other additional considerations, because guardrails are going to take care of that for you. Finally, you've got closing the software development lifecycle loop. So making sure that you're monitoring the app in production and making sure that you iterate quickly to improve it. So constantly assessing the accuracy, completeness, optimizing for cost, optimizing for latency. It's not like the days of a static website where you launch it, you go into hypercare for a couple of weeks and then it's kind of stable. These things are non-deterministic and they'll give different responses each time. So you need to kind of keep on top of things and make sure you're monitoring its behaviors. So that's it from me, and that's it from the workforce planning tool. If you have an agentic problem statement that you're looking for help with, we're running an agentic experience at the moment. So this is a 4-day process in which your commitment will be about a day and a half up front, and then we'll play back some of our findings at the end of the 4-day process. So during that, you'll learn some of the emerging use cases and trends in AI. You'll be able to work with us to discover some of the best use cases that exist within your organization, find and identify the highest value of those opportunities, and then via workshopping, we can then co-design those agents and build out a sort of delivery plan for you, potentially even a proof of concept. So if you're interested, then please do reach out. But that's it from me. Thanks for your time.
Thank you, Gareth, and thanks for joining today's session. If you're interested in a workshop, you can scan the QR code on the screen or reach out to us at ai@versent.com.au to book your workshop. If you have any questions or follow-ups about today's topic, you can reach out to Gareth at his email on screen at the moment. So what's next in the series? We have just one more week to go. So next week, week 10, the 16th of October, our speaker, Ramya Kumar, Technology Associate Consultant, on her talk, Accelerating RFP and Tender Responses with AI RAG Chatbots. So keep an eye out on your inbox for that invite. Thanks again for being part of the Versent AI webinar series. We look forward to helping you unlock the full potential of AI safely, ethically, and with impact. Have a great day, and we will see you next time.